make new formula by multiplying v and dividing by v. Because this one doesn't affect this original equation, right? Because it is 1. So let's modify. So this one, again, d is what? Distance should be positive number, right? So let me make this one to absolute value to make it positive. That makes sense? So what is this? I can change. So let me remind you. If you have a u cross v vector, the definition of u cross v vector was given by the length of u, the length of v, sine theta, and with normal vectors. Normal vector has a unit vector form. So, but if you take the length of this cross product, will be the absolute value and sine theta, and the length of m vector, but this is unit, becomes 1. So what we have, let me erase this part. This is what we have now. So two cross product lengths will be each length product and times absolute value of sine theta. So what I mean, this can be changed to cross product lengths. So we have PS cross V vector over length of V. So this is exactly the same as my formula. So we can derive the distance using the right triangle, sine and cosine, and using the vectors. How was it? Does that make sense?
Mm-hmm.
So now let's do some examples. Example number 5. So we have a line equation, line vector, and also we have a point. So if you have a line equation, we have to find my point P and also parallel vector from the line vector, right?
Mm-hmm.
So again, this is my line. This R over T is given by the vector 1 plus T, 3 minus T, 2T. I can change this one to the parametric line equation because this is X and Y and G component. So X will be 1 plus T, Y will be 3 minus T, G will be 2T. Now this is a line, which we know that. So give me a point and give me a parallel vector by looking at this parametric line equation. You guys remember the parametric line equation definition? Because you guys, no, I did not say homework yet.
Was it X initial?
X was X dot plus V1T, right?
Yep.
Y is Y dot plus V2T, and G dot plus V3T. That was the formula. T is between minus infinity to positive infinity. So X dot, Y dot, G dot, this is a constant in X, Y, and G. This is my point P. And the vector V, parallel vector, is from the coefficient of T variable, which is V1, V2, V3, right? Now let's come back to our line equation. So tell me about my point P now.
P.
1,
3,
3,
2.
2?
Yeah.
2, you sure?
Yeah.
Not 0?
So,
Again, the coefficient of T variable is V vector, parallel vector. So it's same as 0 plus 2T. Right? So the constant should be this. And T variable should be this part. That makes sense? So we have a point P, 1, 3, 0.
oh, okay.
Again, the coefficient of T variable corresponds to parallel vector. So tell me my parallel vector now, V. What's my V1? V1.
1 plus
What is it? 1. Thank you. 1. What about my V2?
3.
Hmm?
3.
Why is 3? Why is 1? Say like what? We have to look at y value, right? You said 1. Why is 1? Which right there? We are looking for this now. Yeah, negative 1. What about G? 2. Thank you. Because the coefficient of this one is 1 times t, 1. This is minus 1 times t. This is 2 times t. So this coefficient number, 1, minus 1, and 2, this is my parallel vector v1, v2, v3. Okay, let me share. My x, 2, 3t, y, minus 1, minus 3t, g, plus 2t. Tell me my point. P.
2, negative 1, 0.
Good. V.
3, 3, 2.
3.
3, negative 3.
Good. And 2, right?
Yeah.
This is how we find the point and parallel vector from the line equation. Okay, let's come back to here. So we have a P and V. What S is given by 1, 1, 5, right? Okay, good. Now let's get PS vector. First, PS vector, by the definition, tell me.
S minus P.
Okay, good. So what is it? 1 minus 1, 0. 1 minus 3, minus 2. 5 minus 0, 5. Good. This is my PS vector. S minus P. And we have a V vector. So first of all, by looking at my formula, we have to find the cross product and length, right? PS and V vectors. So let's take a cross product. So PS cross V vectors. IJK, you guys remember how to find the cross product? And PS was given by this one, 0, minus 2, 5. And V vector is given by this, 1, minus 1 and 2, right? Then we reduce the side to 2 by 2 matrix. So this will be same as I. This one, minus 2, 5, minus 1 and 2. And signs alternating, it's minus J, 0, 5, 1, 2. And K,
0.
0, minus 2, 1, minus 1, right?
I got a question.
Yes,
Why is the J negative?
this sign is alternating. This
Okay.
is how we determine the matrix of 3 by 3 matrix. So please take linear algebra first. Determination of the matrix. It's from the cofactor matrix. Anyway, that's the rule. Y is quadratic formula, B square, blah, 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 right? That's the rule. So let's define. So this one cross minus 4 and plus 5, minus J, 0, minus 5, plus K, 0, plus 2. So we have I plus 5J plus 2K in the vector form 1, 5, 2. Okay, this is my PS cross V vector, right? So now let's take absolute value or length of the vector PS cross V vectors. In other words, we have to find the length of these vectors, right? So this one will be square root 1 square, 5 square, 2 square. This is how we find the length. So it will be 25 and 4, 29, 30. This is my length. So we found numerator square root 30, right? So let's find the denominator now. Denominator is from the length of V vectors. So the length of V vector is given by, where the length, this one, so this is my V vector. So it will be 1 square plus minus 1 to the square plus 2 square. square root 6, right? So by the definition of the distance, so D, again, is given by PS cross V vector over the length of V. That's the definition. So we got square root 30 from the top, and this one is square root 6. So this one is same as 30 over 6, which is square root 5. So this is the distance from the point to the line in space. I know it's too fast, right? To calculate it too fast. But everything makes sense to you. Hopefully. Any question? Go smooth, but you know, the important thing is the formula. Right?
And this section is 12.5, right?
It's still line, yes, plane. But we are playing with line and point now. So let's move to other example. Oh, we're going to move to plane now. So this is about a line, yes.
I have the line below.
The line below
I, parentheses minus 4 plus 5.
plus 5.
Okay.
And minus J, 0 minus 5.
So you
Plus
don't,
K.
so you don't put the 1, you put the I.
What do you, yeah, I, not 1. How was it? So now let's move to plane equation. So let's derive our plane equation. So let n vector is given by A, B, C vectors. And this is normal vector to the plane. And through point P, x dot, y dot, g dot. So let's derive the formula. So what I know, I like to find a plane in space, right? Okay, but what I know, it has a point P dot here, right? And what I know also, I know the perpendicular vector, which is normal vector, it's given by A, B, C. And also, to describe plane equation, my x, y, z should be on the plane, right? So let me say my P point, which is arbitrary point on the plane, we say x, y, g. Good. So now, I like to define a vector P dot P vectors is on the plane, right? But the normal vector n is always perpendicular to the plane. This implies the vector ABC should be perpendicular to this vector P dot P. Do you understand? So what I wanted to say, n vector and P dot P is perpendicular. So two vectors are perpendicular each other. then what they have a property? Which property they have? What condition?
The cross product is 0.
Cross product is 0 is what? They are parallel. Very close. We have one more product. What is it?
One more.
Product.
Dot.
Dot product equals 0. Good. That's why I put dot here. So if you take a dot product between two vectors, then you got a 0. This indicates they are perpendicular to each other. Because cosine theta angle is 90 degrees, so cosine 90 becomes 0. So this is what we know from the previous section, right? So let's derive it. So now first define our P dot P vectors. This is P minus P dot. As you know that, it will be x minus x dot, y minus y dot, and g minus g dot vectors. Good? Good? So now we're going to apply dot product. So n P dot P vector is now A, B, C vectors. Take a dot with x minus x dot, y minus y dot, and g minus g dot vector. But the dot product must be equal to 0 because they are perpendicular. Okay? So you guys know how to find the dot product? Tell me how to calculate this dot product.
X, Y, Z.
You didn't do homework? I assigned the dot product, right? Tell me.
That product,
Two vectors.
okay, AX, A times X.
Hmm? Hmm? 8 times, right? This one, right?
Yeah.
X minus x dot.
Oh,
Plus.
okay.
This one times this, correct? This is dot product. P times y minus y dot. Plus, and g component. C times g minus g dot should be equal to 0. This is dot product.
Yeah. Is this one?
Yeah, this one is dot product. Please. So this one we call plane equation. So what this one says, if you have a point on the plane, also if you know the normal vector, then we can define the plane equation. So let me make a difference. You guys learned about the line, right? The line, we need first point, right? And second, we need parallel vector to define line equation, right? Now we move to plane. We need a point, same thing on the plane. Second, now we need normal vector. Normal is the perpendicular vector to the plane. So from the line, we only change from parallel vector to the perpendicular vector. Then this is my plane equation. How was it? So let me give you an example to describe the plane equation. Example number 6.
Jesus.
Find an equation plane through P dot on the plane -3, 0, 7 and perpendicular vector to normal vector is given by 5, 2, -1. Okay, so this is my x dot, y dot, G dot, because this is a point, right? And this one is normal, which is A, B, C, normal vector. Let's plug in this one into the formula. So what we have, 5 times x minus